Hello, my precious friends. I really hope that you are doing great. Welcome to our today's class. It is our third lesson on the seventh topic of Form 3 work, which is called Electrostatics 2. As usual, let me comment by giving the quote of the day, which states that, "Don't let the dreams in your heart be suppressed by the fear that exists in your mind." We shall discuss that quote at the end of our class today. So today we're looking at charges on sharp points. Remember from our previous class, we did say that charge concentration at sharp points is usually very, very high. So when a highly charged conductor, in this case we are using a wire, is brought close to a flame, the flame is blown away by what we call the electric wind. So we shall see how an electric wind is formed. So if the charge on the wire is positive, such as this particular highly positively charged conductor here, then the high concentration of positive charges at the sharp point of the wire causes ionization of the surrounding air. Remember, ionization is just the process in which an electron is given enough energy to break away from an atom. So if the charge at the wire is positive, then the high concentration of the positive charges, that is the high concentration of this particular positive charges at the sharp point of the wire, causes ionization of the surrounding air. So remember, in between the flame and our highly positively charged conductor or wire, there is air in between here. So if this particular end is highly positively charged, then it will cause the air between our flame and this particular positively charged conductor to be ionized. So the air in between here will be ionized. And remember, ionization will lead to production of what we call the electrons or the negative ions and the protons or the positive ions. Remember, ionization leads to production of ions. Then we have two types of ions, that is the negative ions, which are also called the electrons, and positive ions, which are just the protons. So because of the ionization process, the air in between here will produce the protons and the electrons. Now, the electrons in the air are usually attracted toward the positive conductor. Why are they attracted? Because of the law of electrostatic charges, that like charges will always repel and unlike charges will always attract each other. So remember, the air between the flame and the conductor has been ionized, leading to production of the positive and the negative ions. So the negative ions will be attracted towards our positively charged conductor because unlike charges will always attract each other. At the same time, the protons that has been produced due to the ionization process that is in the air will be repelled by the highly positively charged conductor. Remember, like charges will always repel each other. So because this conductor is positively charged, it will repel the protons or the positive charges that has been produced by ionization process in the air. So as the protons or as the positive charges are being repelled away by the highly positively charged conductor, they cause the flame to divert. So they form what we call an electric wind. So because they are being repelled at a greater force, because remember these are highly positively charged conductor, so because they are being repelled at a high force, it will form what we are calling an electric wind, which will cause our flame to divert towards the left hand side. So electrons in the air are attracted towards the positive conductor. So you can see the electrons are being attracted, while the heavy positive ions drift towards the flame. So they drift towards the left hand side, towards the flame, forming what we call an electric wind. So you just need to know the expected observation. So the observation is that the flame will be diverted away from the highly positively charged conductor. Then the explanation is because of the high concentration of positive charges at the sharp points of the wire causes ionization of the surrounding air, leading to production of electrons and protons. Now the electrons in the air are attracted towards the positive conductor, while the heavy protons or the positive charges or the positive ions drift towards the flame. So because of the drifting or the positive charges which are being repelled, because of the repulsion by the highly positively charged conductor, that is what forms what we are calling an electric wind, and hence causes drifting of the flame away from our positively charged conductor. Then if the wire is brought very close to the flame, remember in this case the wire is somehow far away from the flame, but in this case we are bringing the highly positively charged conductor very close to the flame. So if the wire is brought very close to the flame, then the observation that will be expected is that the flame splits into two directions, such as the one shown here. Then the negative ions in the flame, so remember when you bring a positively charged conductor very close to the flame will be ionized, such that we shall have production of positive and negative ions within that particular flame. Then after that, the negative ions that has been produced due to ionization process in the flame will be attracted toward the positively charged conductor, because remember, unlike charges will always attract each other. At the same time, the positive charges which has been produced by ionization process will be repelled by the highly positively charged conductor, because remember, like charges will always repel each other. So the negative ions in the flame are attracted towards the rod. So because of the attraction, they are being attracted by these positive charges, diverting part of the flame towards it. So as they are being attracted, they divert part of the flame towards that particular positively charged conductor. At the same time, the positive ions are repelled away. So remember, this conductor is positively charged. So it means the positive charges will always be repelled away from this particular positively charged conductor. So at the same time, the positive ions are repelled away, diverting part of the flame. So you can see as they are being repelled, they also divert part of the flame away. That is as shown in this particular diagram. So the most important thing is to know the expected observation. In this case, the observation is that the flame will split into two directions. Then if you're asked to explain the observation, so this will be the explanation, that the negative ions in the flame are attracted towards the rod, hence diverting part of the flame towards it. At the same time, the positive ions are repelled away by the positively charged conductor, diverting part of the flame away from it. So these two diversions causes our flame to be split into two directions. Next, we are looking at the lightning arrestor, whereby we are saying that movement of clouds in the atmosphere produces large quantity of negative static charges due to friction with the air. Remember, under the first lesson of Electrostatics 1, that is under Form 1 work, we did say that we have a process called electrification by friction, whereby we are going to have static charges or stationary charges which are being produced when two bodies or when two rough surfaces move against each other. So the movement of clouds in the atmosphere usually produce large quantities of negative static charges. That is, as the clouds move past each other, we have friction in between them, so we are going to have production of static charges due to friction with the air. So remember, as the clouds move, they also move against air. So because of the friction with the air, it leads to production of static charges. So the negative static charges in the cloud induce large opposite charges, that is the positive charges on the surface of the earth. Remember, the movement of clouds against the air will lead to production of negative charges. So these negative charges will induce opposite charges. Remember, in induction method, we said that the charged body will always have charges which are opposite to the charging body. So in this case, because the movement of clouds leads to production of negative static charges, so those charges will induce, because they are negatively charged, they will induce opposite charges. That is, the charges which are opposite to the negative, of course, they are the protons of the positive charges. So the negative charges produced by the clouds will induce opposite charges or the positive charges to the surface of the earth. So the negative static charges in the cloud induce large opposite charges or the positive charges on the earth, producing a high potential difference between the earth and the cloud. So remember, the movement of clouds against the air has led to production of negative static charges which induce positive charges on the surface of the earth. Now the earth is highly positively charged while the clouds are highly negatively charged. So we have what we call a potential difference between the surface of the earth and the clouds, because the clouds are negatively charged while the earth has been induced with negative charges. So this potential difference, it means that the air that is in between will act as a conductor. That is, it has to carry the charges from the negative cloud as the charges move to the surface of the earth, because whenever we have a potential difference, we are going to have the transfer of charges. So the high potential difference makes the air to become a charge conductor. So the opposite charges strongly attract and neutralize each other. Which opposite charges? Remember, the earth is positively charged now, while the clouds are negatively charged. So the electrons or the negative charges from the cloud will be attracted to the positively charged surface of the earth, while the negative charges on the surface of the earth will be strongly attracted to the negatively charged clouds. So the negative charges from the cloud move downwards looking for the positive charges from the earth. At the same time, the positive charges from the earth move upwards because they are being attracted by the negative charges. Again, remember that unlike charges will always attract each other. So as the electrons move downwards and the protons move upwards, they are going to meet at around this particular region. So remember, when the negative charge and the positive charge meet, they actually neutralize each other. So the high potential difference makes the air become a charged conductor. Therefore, the opposite charges, that is the negative charges from the clouds and the positive charges from the surface of the earth, they strongly attract each other and they neutralize. That is, one positive and one negative charge are going to neutralize each other such that the net charge will actually be zero. So as they strongly attract and neutralize each other, that process of neutralization causes what we are calling thunder and lightning. So actually, thunder and lightning are produced because of the neutralization between the negative charges from the cloud and the positive charges from the surface of the earth. So the neutralization is what leads to production of thunder and lightning. Yeah, you can be asked to describe how thunder and lightning are produced. So you simply say the negative charges from the cloud and the positive charges from the surface of the earth, when they meet each other, they attract each other and they neutralize each other, leading to the production of thunder and lightning. Then remember, lightning usually comes in form of light, while thunder usually comes in form of sound. But actually, thunder and lightning are usually produced at the same point or at the same time. However, when you are on the surface of the earth, you are going to experience lightning before you actually hear the sound that is from the thunder. So the reason is because light travels faster than sound. Because remember that light is an electromagnetic wave, that just as we saw under a Form 2 topic called Waves 1. We said that light is an electromagnetic wave. And remember, electromagnetic waves usually do not require any material medium for transmission. However, the thunder will produce sound, but remember, sound is a mechanical wave which requires a material medium for transmission. So that simply means that light, even in a vacuum or in a material medium like air, light will travel faster than thunder. So that is the reason why the lightning gets first to us before we can hear the thunder. So the reason is because light travels faster than sound. So of course, light is an electromagnetic wave which does not require any material medium, and that is the reason why it will always travel faster than thunder. So when you are on the surface of the earth, you are going to experience lightning before you hear the thunder, but actually they are produced at the same point or at the same time, only that light will travel faster. So lightning can cause destruction to buildings and any other object standing on the Earth's surface. So provided the object can act as a conductor, actually it will be destroyed by the lightning. For example, even a human being, remember, a human being is a conductor because you have water within your body. You also have blood which has ions, which are actually good conductor of charges. So if the lightning and the thunder, if it gets any material that can conduct the excess charges to the surface of the earth, then that material is going to be destroyed. Even buildings are usually destroyed. So any material that conducts the charges or electricity will be struck by that is thunder and lightning. And that is the reason why you will be advised not to walk in that is outside when it is raining, or you are not advised to walk barefooted when it is raining. But you'll be advised maybe to wear some gumboots or any rubber shoes, because remember, rubber are poor conductors of charges. So to prevent lightning from striking our buildings or destroying any objects, we use what we call the lightning arrestors, which are simply used to save buildings from being struck. So the lightning arrestors comprises of a thick copper plate, that is copper wire, with sharp spikes at the top, that is as shown in this diagram. So these are our sharp spikes. Remember, sharp points will always attract more charges. Then these are our copper plate. Then we have a wire that is connecting them. Then the copper plate is usually buried deep down the surface of the earth. So the wire is connected to a large thick copper plate buried very deep into the earth. Then the arrestor assumes the same nature of charges as the earth. So we have said that the earth has been induced by positive charges, that is from the cloud. So because the earth is positively charged, the arrestor will assume the same charge. So if the earth is positively charged, the spikes of the arrestor are also going to be highly positively charged, because remember the arrestor is directly connected to the surface of the earth. So the arrestor assumes the same nature of charge as the earth. Then the high charge density builds up the end of the spikes, and a strong electric field develops between the cloud and the spikes. So because the spikes have the charges similar to that of the earth, which is positively charged, and remember when the spikes are positively charged, remember the clouds here are still negatively charged. So we are going to have a potential difference between the spikes and the clouds. And remember the spikes, because they are sharp points, the charges will be, that is the electric field will be very, very strong or very, very high. So a high charge density builds up, builds up the end of the spikes, and a strong electric field develops between our spikes and actually the cloud. So that simply means that the air that is in between the spikes and the cloud is going to be ionized. So it will be positively and negatively ionized. So the strong field ionizes the air around the point. So the air that is between our spikes and the clouds is going to be ionized. Remember, when it is ionized, it simply means that we have production of positive ions and negative ions, or the protons and the electrons. So the strong field ionizes the air around the points. Then the negative charges are attracted to the spikes. So remember, the spikes are positively charged. Therefore, all the electrons or the negative charges, including the negative charges from the cloud and the negative charges that has been produced in the ionized air, are going to be strongly attracted to these spikes. So the negative charges are attracted to the spikes and conducted away to the earth. So remember, lightning, that is thunder and lightning, can only occur if these electrons or the negative charges from the cloud, they neutralize with the positive charges from the that is from the earth. However, the lightning arrestor, or the spikes of the lightning arrestor, ensures that the negative charges from the cloud, before they meet the positive charges from the earth, that is to cause thunder and lightning, actually these negative charges are taken to this particular spike, such that they do not neutralize with the positive charges from the earth. Once you prevent that neutralization, it means you have also prevented thunder and lightning. So that is how the arrestors work. So they simply take the negative charges from the cloud before they neutralize with the positive charges from the earth to form thunder and lightning. So the spikes, the strong field ionizes the air around the points. Therefore, the negative charges are attracted to the spikes and conducted away to the earth. So all the negative charges, the excess negative charges from the clouds, will be conducted or will be attracted to the positively charged spikes, which will actually conduct them onto the copper plate, which is buried deep down the surface of the earth. So when the electrons from the cloud, when they are conducted to the surface of the earth by these particular spikes, in that case we are not going to have any thunder and lightning, because we have prevented neutralization of the positive and the negative charges from the earth. So basically that is how the lightning arrestors work. So they simply take the electrons or the negative charges from the cloud, and they pass them to the surface of the earth, such that when they pass through here, it means that they have prevented this building from being a conductor that transfers those charges to the surface of the earth. Because remember, if this building becomes the conductor, then we are going to have what we call neutralization, and of course thunder and lightning are going to take place. So in case lightning occurs, the arrestor simply provides a path for the remaining charges to flow to the ground. Because remember, if lightning has occurred and we have some charges which are remaining, they are going to cause thunder. So the arrestor provides a path for the remaining charges to flow to the ground, thus protecting the building. So somebody can ask you to explain how the arrestors prevent the buildings from being struck. So the arrestors, they prevent the buildings, or they protect our buildings by providing a path for the remaining charges to flow to the ground, thus protecting the buildings against thunder and lightning. Yeah, Of course, when it is raining, ensure that you wear some rubber shoes to prevent yourself from being a conductor that transfers the charges to the earth, because you are going to be struck by thunder and lightning. So the aim here, the purpose of the spikes is just to, or the arrestor is just to ensure that the charges flow smoothly to the surface of the earth. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that, "Don't let the dreams in your heart be suppressed by the fear that exists in your mind." So yeah, most of us are afraid of pursuing our dreams just because we fear. That is, just because we fear. That is, we fear how our friends will judge us. We also fear what could happen if we tried pursuing our dreams and failed. Yeah, that is, we fear failure. We also fear other people's opinion. But guess what? I'm here to remind you that what other people think and say about you should be none of your business. Just focus on you. Just focus on becoming a better version of yourself. And lastly, recall that you will never achieve your dreams unless you become courageous enough to overcome your fears. Yeah, I'm just here to remind you that many people, many dreams have failed just because of the word, "What will people say?" So do not be dragged behind from achieving your dreams by fearing what other people will say. Just focus on yourself and focus on becoming a better version of yourself. So don't copy others. Instead, build what you naturally feel passionate about. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. In case you know any student or anyone that you honestly think could benefit from this content, kindly refer them to Kind Tuition Academy, or just share my link to them either through WhatsApp, Facebook, or any other social media platforms. Thank you for your continued support. Until next time, this is Kind Tuition Academy.